Okay. So this is a tutorial for the conservation of energy lab, conservation of energy and the work energy theorem. This lab is fully based on this online simulation. So if you go into this app, you're gonna go into the interactive simulations and you have to select measure. All right. So basically the idea with this lab is that you build a ramp. You're gonna build a ramp without friction, and you're gonna calculate or you're gonna measure the kinetic and potential energies initially and finally. So I will start with this. So you can see the grid, 2 meters, 4 meters, 6 meters, 8 meters. On the table, you can see that I start with 8 meters, so we can place this here. That's the initial position for the skater. Adjust the mass, however you want this. I leave it at 60. No friction. You want to have the speed. And this is important because that's your readings of energy. Now, you're going to read the energy with this. But to use that, you need to let this skater roll. Now, on the lab, you also have a figure, and I specified that the last height should be 4 meters. So leave it there around here. That's your initial position, that's your final position. There. You can do a few test runs to see how this works. And don't worry if this happens. You see all these dots? Those are the dots that you're going to use to measure the final and the initial energies. Now, you see how they disappear. So you use the slow motion if you want, and you want to pause this. So basically, try to leave it here. And then you see you get more dots that way, and then stop it there or pause it there. If I drag this in here to the initial height, to the height of 7.91, that gives you an initial potential energy, an initial kinetic energy. Thermal energy will be 0 because there's no friction. And then you want to go at the last position here. The height is that speed. So you may want to adjust the heights here because the energies will be conserved, but there is potential and kinetic as you expect here, but there is some kinetic here. And that's because it's measuring not at 8 meters, but at 7.91 meters. So when the skater has gained some speed. So you may want to adjust that. And then once you do that, you want to change this. So we can change this to, let's say, 6 or 7 and repeat the experiment. And then let it go, and then be the same, right? There. And then you see that's, again, not at 7. So you have to write down both the initial kinetic, initial potential, final kinetic, and then you want to calculate the difference of energies. That's basically done on the second section. When you write the mechanical energy is the sum of potential and kinetic. All right, don't forget. There might be an error, there might not be. At the beginning, you just want to measure these values. And there you go. Now, not very difficult. The second part, however, is where you have to do some calculations. So here you're going to investigate the work energy theorem by adding friction. So there are a few things you have to do in the second part. First of all, you want to make sure that the height first is 6. And you want to have a semi-straight path here. So That's why I chose 6. And you can even do this with 4 later. But you see, it's sort of straight up until here. So there might be some percentage error because of this. Regardless, you want to add some friction, not a lot. And then you want to, again, release the skater from here. And what's going to happen now is, and you can even stop it there. There will be some thermal energy. This has to be disregarded because that's due to friction. So you want to add the kinetic and potential, and you want to add here the kinetic and potential. Because the difference will be now considerable because there's friction, right? In fact, it should be the thermal energy released by the friction, but let's see. So final will be 3118 plus 6.1, 3124.1. Okay, that's your final mechanical energy. Oh, I made a mistake here. My bad. I have to repeat this. Why did I move this? Okay, that's fine. So let's do this again. Perfect. Okay, so again, it changed a little bit, right? Okay, so that's your final at this position, your final mechanical energy, and your initial mechanical energy is here, which is okay. So let's write that down. So initial mechanic is 3495.5 joules. Final mechanic energy is, let me show that again. So the difference, so this difference is the work done by the friction, which is close to this, right? So it makes sense. Therefore, you can calculate the force due to friction by using work equals of force times distance. What's the distance? Well, distance comes from this, all this. So you can assume this to be a hypotenuse. This is 6. 1, 2, 3, 4, 5, 6, 7. 6 and 7. You can do the Pythagorean theorem. That will be 36 plus 49. 9.2 approximately. So the distance is around 9.22 meters. So the force due to friction is 383.9 divided by 9.22. 41.6 newtons. So there you are. That's how you do this section of the lab. So there are more calculations in the second part. All right, I do show you the model here. That's basically what you have to do. Okay. If you have any questions, remember you can send me an email. I hope this video is clear, and make sure again you're using the measure stimulation. You need to be able to use this. All right. Okay.